Hi again, Year 10. It's Mrs. Church doing an electrolysis video. We've got some solid zinc chloride and we want to separate the zinc chloride into zinc and chlorine. To do that, we need to melt it because when it's a solid, the ions can't move. But when we make it molten, a liquid, the ions can move and we can use electricity to separate this compound. This is the equipment we're going to use and we're going to set it up for you. So we've put the solid zinc chloride in the crucible here with the two electrodes sticking into it. If I try and put electricity through it now to separate it, the bulb doesn't light and nothing's happening. Because it's a solid, the ions can't move and that electricity can't flow. So in a minute we're going to make it molten, but I just want to remind you, if this is the positive side, what would this electrode be called? Can you remember the positive electrode? It's the anode. And the negative electrode, can you remember its name? It's the other side, and that's the cathode. This is the one here. So think about my zinc ions and my chloride ions. Which ion is going to go to which electrode? See if you can predict it as the video carries on. But now we're going to light the Bunsen. So we've lit the Bunsen and it's on a hot roaring flame in order to melt the zinc chloride. It hasn't melted yet, and so although that the electricity is running, the bulb hasn't lit. We'll know it's melted when this bulb starts being on.
Can you see it's on?
So now we can see that the bulb, although dimly lit, is lit. And that's because, if you can look carefully, can you see that the zinc chloride has melted? We've got zinc coming off at one electrode, so zinc ions are metal and they're positive. So they're going to go to the negative electrode, the cathode, and the chlorine that is being made is a negative ion, so it goes to the positive anode, and if I hold the blue litmus close, you should be able to see that quite rapidly, really, the blue litmus turns red to show the presence of an acidic gas and will then be bleached. Because even more of the zinc chloride is melted, the bulb is actually glowing quite brightly now. So here we have the liquid zinc chloride. I'm very carefully, can you see it's a liquid? I'm going to try and pour off some of this solution and see if I can see a little bit of the zinc metal. It should be left at the bottom. This is very hot. I can't see anything in there. Maybe if we let it to cool a tiny bit more, I might just pour it back in and see if some of the metal is there. Hopefully you can see it beginning to solidify. The little grey dots of zinc. So that was molten electrolysis. The apparatus can look a bit cluttered in real life, and on the exam paper often they use exactly the same diagram as they do for solutions of electrolysis, but just label the electrolyte molten rather than solution. And you need to be aware that that is the only change you're looking out for.